Well, welcome everyone. My name's Stuart Cunningham and I'm a software engineer for Blackmagic Design, and I'll be giving you an introduction to the Video Hub Router Control Protocol. Now, video hubs are used in broadcast for routing video signals between inputs and outputs, and we have models ranging from the 12 by 12 smart video hub, a 40 by 40 model, and a 288 by 288 model. What does the video hub router do? Well, it connects inputs to outputs, and I like to think of it as simply connecting a wire from the input to the output. If we make a change to the video hub route, we get something like this, where outputs 1, 2 and 3 are connected to input 1. And the other thing to notice is that inputs 2 and 3 aren't connected to anything. That's okay. Inputs don't have to be connected to anything, but outputs are always connected to an input. So video hubs are controlled remotely using an Ethernet-based network protocol, and I'm going to give you an overview of that. It's a TCP network protocol, and the video hub is the TCP server, while the control clients connect to the video hub on port 9990, and it's a text-based protocol, so it makes it very easy to understand the protocol and to debug it. You can use Telnet to do so. The text format is fairly straightforward. We call it a command block format. And a command block consists of a block name, which might be video output routing, and a number of values that you want to change. You terminate the block with a new line, an empty line. That gets sent to the video hub, and then the video hub will respond immediately with an acknowledgement to acknowledge that it received your message. If you made a mistake in the syntax of the command, it'll give you a NAC rather than an ACK. So you'll know immediately whether it was received correctly. And then a short time later, after your change has been applied in the device, you'll get a status update. And that takes the same format as the command, and it lists the values that you changed. So I'll go ahead and give you an example of this with a Telnet session. Now, I'm using Telnet here, but if you're on Windows, then using another client such as PuTTY is reasonable. So let's go to Video Hub 1, port 9990. And as soon as we connect, we get a lot of text which indicates the current state of the device. You also get some information about the device, such as the number of inputs and outputs. That information is useful if you're going to be automating something with a script. You can work out the range of inputs and outputs that you're dealing with. Everything that the Video Hub control software sees is the same. It's just a client. So just as I connected with Telnet and saw all of this, when the software connects, it gets the same information. And it renders it with these nice buttons here with the labels and the locks showing. And then towards the end of this, you have probably the most important part, which is the video output routing table. And in this one, it's got just a default setup where every input is connected to the same numbered output. So output 1 is connected to input 1. So I'll demonstrate how you would change this. So I've typed in the command name, and I'm going to make output 0 connected to input 1. Now, computers like to start counting from 0 rather than 1. So in the protocol, it's numbered 0, but on the user interface, it's numbered 1. That's true for the inputs and outputs. So I'll connect output 2 to the same one, just like in the example on the left, and I haven't sent it yet because I've got to enter that new line. As soon as I enter that empty line, we should see the route change here, and it's changed. So my change has had an effect. If you're quick, you would have seen the ACK come first, and then a status update which is listing the routes that were changed. We can change a few other things. So I'm going to change the output label here. Now, if you forget the name of any of the commands, you can simply scroll back up from your initial telnet connection and just copy and paste the name of the command. So I'm going to paste that down here, output labels. I'm going to change the label here to be something else, such as gallery 1. You can have spaces in there if you like. Now, nothing's happened yet because I haven't sent that new line. As soon as I send that new line, you should see the name change there to gallery 1. Now, the other thing about the protocol is that if you just connect to the video hub and you don't make any changes, you'll still get status updates. So this telnet client is still connected to the video hub, and if I'm going to go and make some changes on this client, you should see them show up over there. So let's go, we'll select output 1 here, which in the protocol will be 0, and I'm going to change some of those. Every time I make a change, you'll see it change there. You'll see it change here, and also in the telnet window. So that can be used by clients connecting to the video hub to see the current state that the other clients are changing. Now, a fairly common thing that we've noticed customers doing is they want to do what you might call a preset. So they'll come into an edit suite and they'll say, well, I want all my video hub routes set up a certain way, and they'll have just a text file sitting on the desktop which they'll highlight, they'll copy it, and then they'll simply paste it into the telnet session like that. They'll send the new line, and you should see the route change. And that's good enough for many people. We're quite happy with that. I prefer to use a script. So I'm going to bring up a Python script. You see the Python script there. I'll just close my telnet client so you can see that. So I ran the Python script, and you saw the route change. The Python script's fairly straightforward. You make the connection just like you would on the telnet command line. So you connect, you wait for the end prelude, which is all of the initial status, and you simply send that text with the empty new line. And I always like to include that last line, which is to wait for the ACK. And if that ACK doesn't arrive within the 5-second timeout I'm using, that means either the video hub wasn't connected, there was a network problem, but either way around, if I had a mistake in there, I'll get an error. The Python script will give me an error, and I'll know straight away it hasn't worked. Another common use is in CCTV and security cameras. People will use a video hub to cycle through different camera inputs. So let's go ahead and run that script now. So you can see the route changing here. Once a second it's going through. So this Python script connects in the same way, and then it changes the input connected to output 0, sleeps for 1 second, and then increments the input number. If it gets greater than 6, it wraps around back to 0, and that's what you see happening here. So it's cycling through 7 inputs, and that's a perfectly reasonable way to use the protocol. Customers will often, because it's just a network-based protocol and you can use Python scripts, people will often run this sort of thing on a Raspberry Pi connected to the network, and they'll just lock that away in the cupboard and it just sits there doing its job. So another use case is tally. So if all you've got in your organization is some video hubs and network, and you don't have the infrastructure for camera control and tally information, you can run a script which will connect to the video hub and then listen for changes. So this script isn't making any changes, it's just a client waiting for status updates. And what it's waiting for is any change on output 0. And if it changes to input number 3, it'll print turn on tally. If not, it'll print turn off tally. So I'm just going to change that. So turn off tally, turn off tally. As soon as I go to this one, which in the protocol is input 3, it'll say turn on tally. Now, in reality, you'd probably connect that to using a GPIO pin to a light. So if this was running on a Raspberry Pi, you'd uncomment that line, you turn on the signal there, and that would turn on the light or turn it off. The other thing people like to do is use some physical buttons for their presets. So again, if you're going into an edit suite in the morning and it's been used for different purposes overnight, you might want to just press a button, not have to open up a laptop, run a script on the desktop, whatever. Having a physical button is preferable for many people. So they will press the button and the Arduino will send the routing table to the router, and it's all done. The next user will set things up a different way, using a different preset. So when you're using a Arduino, you need an Ethernet shield. So there's the Arduino Uno there. The Ethernet shield, it uses up 4 pins for communications with the Ethernet shield. And that leaves plenty of digital pins and analog pins left over that you can connect to buttons and LEDs. So on this one, I've got 3 buttons and 3 LED lights. And there's still plenty of room for anything else that you want to connect. Now the source code for the Arduino sketch is a little bit more complicated than the Python scripts you saw earlier. You've got to do a bit more setup. You've got to set up your MAC address, that's your network MAC address. Then you've got to set up your connections, the pins for buttons and LEDs. So I'll just scroll through most of that. Connection management, it's a little bit more involved. But ultimately you'll get down to here, and it's simply getting a button. If a button was pressed, it'll send the video routing command. And it's identical, of course, to what we did in our telnet session. If you press button 1, send this video output routing configuration. Press another button, you'll get another one. So really quite straightforward. In fact, all of these examples are very accessible. And if you want more information, in the back of the Video Hub installation manual, we've got the reference for the protocol format. And we've got more information on our developer support site. There's also the developer forum. And we've got an email address for developer support as well. Well, I hope you've enjoyed this. I hope you can see that it's really quite simple to do remote control of the Video Hub. You can use copy and paste into a telnet session. You can run a Python script, or if you want some physical buttons, you can set up an Arduino. I hope you enjoyed the talk and have learned something about controlling video hubs. Thank you.